Hello, this is SensorLAB. In the last video, we introduced a precision multi-turn absolute position sensor that uses a gear-type scale optimized for use in robots. For a basic introduction video, please refer to the link in the description below or the link at the top of this video. This time, we will explain and demonstrate the function of simultaneously receiving multiple position data from multiple sensors with a single cable, which is essential for collaborative robots. First, we will briefly show you a video of receiving data from 4 sensors, and then we will explain in detail. As you can see, 4 sensors are arranged around one gear and connected in series. We receive 4 position data from 4 sensors over one cable. You can see 4 positions changing in the program for the master. As in collaborative robots, when a motor, sensor, and single-axis, servo, controller are in one actuator, one sensor is mounted on the motor shaft and the other is mounted on the output shaft of the reducer. A single-axis controller should receive position data from both sensors simultaneously. Fanuc, one of the world's largest robot companies, sells not only collaborative robots such as universal robots, but also industrial robot-based collaborative robots. A precision sensor is mounted on each output shaft of the reducer mounted on the robot's 6 joints, and is used for teaching mode and shock detection. The robot controller should receive the position data from the 6 sensors mounted on the joints. In summary, in a collaborative robot similar to the universal robots, the single-axis controller must receive position data from 2 sensors for each joint actuator, and in an industrial robot-based collaborative robot, the controller must receive position data from 6 sensors at joints. In service robots and wearable robots, hollow shaft sensors are mounted on large joints such as the waist and legs, and receiving position data from multiple sensors with a single cable has many advantages over receiving it through individual cables. We recommend using BiSS communication to receive multiple position data at high speed. The protocol for receiving position data from most servo sensors or encoders is one-to-one communication. Considering CAN, EtherCAT or Profibus, do you think one-to-many communication is possible when using servo sensors? There are many differences between sensor communication protocols for high-speed feedback control and communication protocols for motion networks. When using sensors for monitoring, you can apply motion network-based communication such as EtherCAT or Profibus. But you cannot use it for servo control. While the motion network communication cycle is mainly hundreds of microsecond to several millisecond, sensor data communication for high-speed feedback control transmits only essential position data at high speed with a cycle of less than 30 to 100 microsecond. We explain the configuration of a demonstration device that receives position data from 4 sensors with one cable. It consists of 4 position sensors and MB5U, a BiSS master kit that receives position data, a laptop to display position data, an oscilloscope to measure communication waveforms, and a power supply. We explain the principle of receiving position data by connecting 4 sensors in a series daisy chain. The clock signal requesting position data from MB5U, the BiSS master kit, is transmitted simultaneously to 4 sensors. First, the slave 0 sensor located at the end of the master transmits position data to the slave 1 sensor right in front. The slave 1 sensor attaches the position data received from the slave 0 after its own position data, and transmits it to the slave 2 sensor right in front of it. The slave 2 sensor attaches the 2 position data received from the slave 1 after its own position data, and transmits it to the slave 3 sensor. The slave 3 sensor attaches 3 position data received from the slave 2 to its own position data, and transmits 4 position data to the master. In order from the sensor furthest from the master to the sensor closest, it is slave 0 to slave 4, and at the same time, it is channel 4 to channel 1. In this way, the master receives 4 position data synchronized to the clock signal. We will show the master and the notebook receiving position data. As you can see, 4 gear coders are placed on one gear at about 90-degree intervals and connected in series. On the GUI, 4 positions are displayed on data channels 1 to 4, respectively. I will slowly rotate it by hand. The first data of each channel is the number of revolutions and the second data is the absolute position of a single rotation. For the 4 sensors, multi-turn data was set to 8 bits and single-turn data was set to 20 bits. Considering the position data length and communication time, the single turn data was set to 20 bits, but it is possible to set it to 22 bits or more. When a single position data is incremented by 20 bits or 1,048,576 counts, the number of revolutions is increased by 1. We will show the changes in the positions of the 4 sensors in a picture similar to a clock. Since the positions of only 2 channels can be displayed at the same time, we will show you by switching the channels of the red and green hands. Since the origin is not set accurately, each sensor is not positioned at 90 or 180 degrees, but you can see that they rotate at the same speed and direction. You can see that the single-turn data for 4 channels gradually increases, and when it reaches 20 bits, the number of rotations increases by 1. Let's measure the time to transmit and receive position data from all 4 sensors. Oscilloscope channel 1 is the position signal sent from slave 3 sensor, and channel 2 is the clock signal sent from master. The speed of BiSS communication is 5 MHz. The data length of one sensor is 36 bits, 8 bits for multi-turn, 20 bits for single turn, 2 bits for errors and warnings, and 6 bits for CRC. There are 4 sensors, so a total data length is 144 bits. The data communication time is 28.8 microsecond, and including CDS and timeout, the total communication time is 31.3 microsecond. If the robot controller receives position data from 6 sensors, the total data length is 216 bits, the data communication time is 43.2 microsecond, and the total communication time is 45.7 microsecond. The following is an example of applying 6 sensors to the robot. The length of position data for one sensor is 40 bits, 12 bits for multi-turn, 20 bits for single turn, 2 bits for errors and warnings, and 6 bits for CRC. There are 6 sensors, so a total of 240 bits. Data communication time is 48 microsecond and total communication time is 51.1 microsecond. In this way, in robot applications, although there is a difference depending on the number of sensors and the length of the position data from 6 sensors can be received serially using one cable in about 50 microsecond. In the next video, I will talk about the absolute position recognition principle, battery consumption, BiSS communication, etc. If you turn on notifications, it will be more convenient when you watch the next video. Thank you for watching. SensorLAB.